Hello children, today's topic is P20.4 Kirchoff's laws and cells. Kirchoff's laws we use to analyze complex circuits, in the sense the circuit which is not reducible by series and parallel formula of resistors. For example, R is equivalent to R1 plus R2 plus R3, 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Such kind of formulas we cannot use in some type of circuits where there are more number of batteries and more number of resistors, and you can't, by seeing the visual, you can't say which one is series, which one is parallel. Multiple resistors and multiple batteries are involved. Then we have to use Kirchoff's laws. Kirchoff has given two basic laws, KCL and KVL. Kirchoff's current law, Kirchoff's voltage law. One we apply at a junction, the place where wires meet. For example, wire goes like this, is called wire jumped. So wire is going one over the other. So if you cut the insulation and join it, so inside copper wire is there, copper wire of one and copper wire of other, when they are joined, again we put the tape. That kind of thing we call it as junction. So this is a junction. And here loop rule. So you start from one point, come back to that point, traversing a loop, or it looks like a mesh. Multiple loops look like a mesh rule. Basically this is defined like this, stated like this: algebraic sum of currents at a junction is 0. Here KVL is defined like this: algebraic sum of potential drops and rises wherever, according to the battery, at one place you may have a rise, in one place you may have a fall. So potential rises and falls, basically potential differences. Starting from a point, if you come back to that point, because conservation of energy happens, so potential algebraic sum of potential differences is equal to 0. This is basically nothing but law of conservation of charge. Some say 15 coulombs of charge comes through one wire and it goes into two other wires. In one wire 5 coulombs goes, remaining 10 coulombs will go in other wire. So basically it's nothing but charge conservation, but per unit time, because current is charge per flow per unit time, you divide it with time. In a given time, whatever charge is coming is getting distributed. So there is no accumulation of charge at junction. That is one way of looking at this law. Potential differences. What do you mean by potential difference? Work done per unit charge, or energy difference between 2 points per unit charge. So when 1 unit charge flows through that, how much energy either it gains, how much energy either it loses between those 2 points. That's the basic thing here. So this is related to conservation of energy. Even though this is basic conservation of charge, but it is not to be just look like charge. Here currents are involved. So he applied for a particular case of circuits where current is coming and going. Here also it's not just energy. Here it's potential differences. In a circuit, he has taken from one point, it traversed to different places and came back to the same place. Then energy is conserved. That he wanted to say. So even though it's a manifestation of charge conservation, this is a manifestation of energy conservation, we look them at like this only. That is, algebraic sum of potential differences is 0, algebraic sum of currents is 0. This related to junction, this related to a loop. Let us come back, take a physical example here so that you understand it better. So some currents are coming, some currents are going like this. If I name them as I1, I2, I3, I4, I5, you have to follow certain convention. Either you take incoming current positive or outgoing current positive. So I take outgoing positive. So which are the outgoing currents? First check it out. I3 is going out, I4 is going out. Plus I3, plus I4, outgoing currents. You have to make sum, that's why in between sum, plus and minus according to your convention. Incoming currents, I2 is incoming, I5 is incoming, I1 was outgoing, so I1 also I take positive. I1, I3, I4 are going out, I1, I3, I4 are going out, I2 and I5 are coming in, plus of minus I2 incoming current plus of minus I5 is equal to 0. If at all we make the opposite sign convention, doesn't matter. This thing will get minus, 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 plus, plus. The currents which you took minus become plus, the currents which you took plus become minus. Minus terms you take that side, LHS is equal to RHS will come. So doesn't matter that what you take, but you follow certain convention throughout your calculations. Coming back to this, let us take this battery is of EMF E1, this battery of EMF E2, this battery is EMF E3. Let us put this battery like this. E4, resistors R1, R2, R3, R4, R5. Numerical part we do it, but first let us do it like this. Professional trick is, out of all the batteries, whichever battery EMF is highest, that you concentrate first. Say E4 is highest. So from that E4 you take the current out, I. And once current I is going out, I will come in. So in this branch again here, as there is no split, this is I. As there is no split here, this is I. And here there is a possibility of splitting, split it. So this is say I1, this is say I2. I2 goes like this, I2 goes like this, I2 goes like this, I2 goes like this, this I1 comes like this. If you focus your attention, I splits into I1 and I2. I1 and I2 reunite to give back I. So you already used charge conservation unknowingly at this junction and at this junction. That means you use Kirchoff's current law. Now comes, for convenience of students, let us write these points as A, B, C, D, E, F. Now start from one point, come back to other point. That same point is called loop. Let us start from A. A, B, C, E, F, A. This is a loop. Started from A, came back to A. In the process, you have to go in that direction. Now see, current always flows from high potential to low potential. Battery have plus and minus because the big bar is plus, small bar is minus. Big bar is plus, small bar is minus. Resistance don't have plus minus. So you have to give it. So already you have made some I taking the EMF of highest battery, say E4 is highest out of all 10 volts, 12 volts, 13 volts, 25 volts. From there you took current out. That's a professional trick. Mostly it will come right, otherwise it will come negative answer. So this is plus, this is minus. As you are coming like this, not this current is not going, this current is coming. So this is plus, this is minus. Current is coming like this. This is plus, this is minus. Current is going like this. This is plus, this is minus. Once you put the signs, see this diagram is segregated into three parts. First, before writing the currents, one circuit. After writing the currents, second circuit. Third circuit after writing plus minus signs. Enough. So three type. When you are pause the video, first you take down the first diagram. Second you take the second diagram after writing ice. Third you take plus and minus. Now start from here. Plus to minus. You are coming from high level to low level. You can take it as a drop. Drop is given as minus. And current is I2 R1. B is equal to IR like that. I2 R1. This is a drop, minus sign. Plus, because of summation, you have to take plus. And from B, you are not going to C, B to E. You are going from B to E. In the process, you came from plus to minus, drop. Minus E2, EMF of that battery in volts. You are going from minus to plus. You came from plus to minus, drop. Minus to plus is rise. Plus of plus I1 R4. Plus. Going from plus to minus, drop. I2 R3 minus I2 R3 plus. Coming from here, after E you have to go towards F. After F you have to go towards A. After E to F, F to A. Minus to plus, you are rising. Plus E3. Not at all, I am continuing here. Plus here. plus 2 minus is a drop, minus 2 plus is a rise. I2 R2 plus minus 2 plus is a rise plus E1. You came back to A 0. This is the way we are written for this loop. Suppose you want to take B, C, D, E, B. B, C, D, E, B. Let us take that. This place is needed for me. I will take it here. B, C, D, E, B. It's another loop. So I started from B to C. There is no resistor. There is no gadget which eats energy or pumps energy. So here you are going. And current is going like this. This is plus, this is minus. I forgot to put it. Now plus 2 minus drop. Minus IR5 plus minus 2 plus is a rise plus E4. Next, nothing here, comes like this. Plus 2 minus drop I1 R4 plus 2 minus drop minus in between plus minus 2 plus is a rise. Minus 2 plus is a rise plus E2. You came back to B, so it's equal to 0. So this portion, when you are traveling A, B, E, F, you are going from B to E. This portion, when you are coming B, C, D, E, F, you are coming E to B. So when you travel B to E, E to B, quite opposite signs you will get it. E2 in first equation got minus sign. E2 in second equation you got plus sign. I1 R4 got plus sign in the first equation. I1 R4 got minus in this because we traversed in opposite direction. That common thing will take care of sign. If you made any mistake in the sign, when you are doing calculation, when you are solving these two equations, the mistake what you made in the direction of current, for example, you have to assign current right side, but you are assigned left side, which is wrong. Then your both equations are wrong in the sense direction wise. So what you have to get here, you will get here. What you have to get, opposite things you will get it. If you travel properly, if you proper plus and minus sign, if you write it. So that algebra will take care of it mathematically, and you will get back the answer. Instead of getting I1 to be a positive 5 amperes, you will get minus 5 amperes. Minus 5 amperes is 5 amperes is the magnitude, minus is the direction. That means whatever sign direction you assign, quite opposite you have to take into account. So this is explanation of Kirchhoff's current law and voltage law. Now you can, if you want, you can put the numbers like this. Just a moment. One ampere, 2 ampere, 3 ampere, 4 ampere. Don't even write 5 amperes for this. We don't know how much is that. So I you put it. That's what we are finding. Because we don't know, by just putting orally 1, 2, 3, 4, we cannot get the proper answer. So some current comes and many things goes like this. So I, incoming current, let us take positive. Okay, incoming you can take positive. Any other incoming currents are there? This is an incoming current. Plus 3. Outgoing, outgoing, outgoing. 1 ampere, 2 ampere, 4 ampere. Minus, minus, minus. In between plus is equal to 0. So I is equal to this 3 plus of minus this gets cancelled. So 4 minus 4 goes outside, 4 amperes. And you got plus 4. What does it plus 4 means? For example, you have taken I inverse is positive. So 4 plus 4 should come in. Inward current. If it comes minus, it's an outward current. Like that. Even here, you can remove R1 you write 2 ohms, R2 you write 3 ohms, 7 ohms, 5 ohms, 4 ohms, 12 volts, 10 volts, 3 volts, 4 volts. Do the problem as it is. And while solving, you get one equation for this loop, you will get one equation for this loop. If you add both, you will get equation for A, C, D, F, A. This term, once you get plus, once you get minus, you get cancelled. So you can't get 3 equations out of this. You can get only, some students say that there are 3 loops here. This is one loop, this is other loop, this big one is another loop like that they think, which is wrong. There are only 2 loops here. So how many loops if you count it overall? Minus 1, because one of them will be like corollary or lemma of a theorem in mathematics. Same information they give it in other form. So here, once you are coming like this, once you are going like this, that part gets cancelled. You get for the overall thing. That's not going to be an independent equation. So you got 2 equations. You have to solve and get the I1 and I2 values. Students, one of my students asked a silly question, but answer is serious related to that. So for example, this battery is 20 volts, 2 ohms, 3 ohms, 4 ohms, 5 ohms, 6 ohms, 7 ohms, 8 ohms, 9 ohms, 12 ohms, like that. Some resistors have been there. He wants to know like this. I know that this is V and this is I, this is R. Why can't I use V is equal to IR and write 20 is equal to I into this 2 and get current as 10 amps. What's the mistake in this? He asked one of the student. So I call it as a silly question, but at the same time, question is a question. We cannot segregate a question to be silly or serious. It's his doubt. So answer is this 20 volts is across all of them. If you know potential difference across this resistor, this end, and this is resistors that end. If you know potential difference across this, for example, this is 2 ohms only. Out of those 2 ohms, here and here, out of this 20 volts, say this point is at some 8 volts and this point is at some 4 volts. And you know potential difference is 8 minus 4 is 4. Then you can do V equal to IR here. That is delta V equal to IR. But you are not supposed to do for the total. So here, we are trying to learn something new where the single battery or multiple batteries are given. We are not interested in that. And across every resistor, before and after the resistor, what is the energy difference per unit charge flown or potential difference across each resistor? To do that, we have to start with a very simple case and should go to a very complex case. So in each of the cases, I am trying to show you the AB difference. So here say 2 amperes is current is flowing through 10 volts resistor, 10 volts battery. Now, if you go from A to B, say A is 0 volts, B is a drop of big bar to small bar, drop of 10 volts, so this should be minus 10 volts. Similarly, irrespective current with the flow right side or left side, if A is 0 volt, we are coming from big dash to small dash, energy difference is decreasing. So plus to minus drop, again it is minus 10 volts. No, suppose this itself is 10 volts. This itself is 10 volts. Then 10 has to drop by 10, so this becomes 0. 10 has to drop by 10, this becomes 0. If at all this is 100 volts, A is at 100 volts, difference should come same. What I finally want to say is 100 volts. Whether current go like this or go like this through a battery, then battery is functional. 100, a drop of 10 volts, this should be 90 volts. 100, a drop of 10 volts, it should be 90 volts. So whether you take 0 minus of minus 10, 10 minus of 0, 100 minus 90, answer should come 10 volts. That's a drop. Plus 2 minus. This is about a battery. Coming to resistor, this is a problem. I told you already, battery will have a big bar plus and small bar minus. Current may go like this or like this, same. But in case of resistor, if current goes like this is plus, this is minus. If current goes like this is plus, this is minus. Say A is under a potential of 100 volts, like previous 100 volts. You are going from plus to minus. Plus to minus is a drop. 5 tens are 50, a drop of 50. Minus 50 is equal to this voltage. If this is say 4 amps, then minus 40, this will be at 60. Okay, let us take 4 amps. 4 amps current. and the terminal just before the resistor is at 100 volts. 100 minus plus of minus 4 into 10, 40. That gives potential of this point B. 100 minus 40, 60 volts. And if A is at a potential of 100, minus 2 plus is a rise, plus of, plus, let us take 4 amperes only. 4 tens are 40, 140 volts. So when current gone like this, it gave 40 volts to this gadget. 100 minus 40, this point became 60 volts. When it is coming like this point was at higher potential. That's why current flown like this, from higher potential to lower potential. Current always flows through a resistor, not through a battery, through a resistor. So this is at 140 volts. It dropped to 40 and here it came out to be 100, like that. Now comes both. There is a battery as well as a resistor. There is a battery as well as a resistor. Let us take A is at a potential of 100 volts. Current is coming like this. So this should be plus, this should be minus. How much current? 5 2s are 10. So plus 2 minus. From that side if you come, is a drop. From this side if you go, minus 2 plus, it's a rise. Plus 5 2s are 10. Drop of 3 volts, minus 3 is equal to the voltage of this point. 110 minus 3, 107. So B is at a voltage of 107 volts. Now current is going like this. Say A is 100 volts. This is plus, this is minus. Current as it goes from high potential to low potential. So 5 amperes of current is flowing through this part of the circuit. It's a part of circuit, not the full circuit. 5 2s are 10. Plus 2 minus is a drop, minus 10. And 3 volts also, there is a plus 2 minus, there is a drop, minus 3. So the answer is 100 minus 10, 90, 90 minus 3, 87 volts. So voltage of B is 87. Previously it was 107. Try to understand these distinctions. Before the resistor and after the resistor, you should be able to tell the potentials. Say this is 2 ohms, 3 ohms, 4 ohms, 2 volts, 4, 5 volts, 6 volts, 7 volts. And this is the terminal A, this is the terminal B. And you are starting from say 100. And the current is going through like this, which is say, convenience sake 5 amperes. Multiplication becomes easier. 5 2s are 10. Out of 100, there is a drop of 10. So this point will be at a potential of 90 volts. Again there is a drop of 5 volts. Plus 2 minus there is a drop. Plus 2 minus again there is a drop. So this point will be lesser than this. And this point will be at 85 volts. Minus 2 plus there is a rise. 85 plus 6, 91. So this point will be at 91 volts. 5 amperes coming through this. 5 3s are 15 volts. Plus 2 minus. Current flowing like this within one part of the branch. So plus 2 minus is minus 15 volts. 90 minus 15. 91 minus 15. 90 minus 15 is 75 plus 1. 76. This point is at 76 volts. Minus 2 plus it's a rise. Rise of, here there was a fall. Here it's a rise. When there is a fall, we will subtract. When there is a rise, we add. 76 plus 7. 83. This point is at 83 volts. Now, current is coming 5 amperes. 5 4s are 20. Plus 2 minus. There is a drop. 83 minus 20, 63 volts. This point is at 63 volts. Now you got not the potential difference from A to B. You got potential difference across 2 ohms. That is 100 minus 90. 10 volts drop. Here there is a drop of 5 volts, which is the battery is taken care of. Here there is a rise of 6 volts. 85 to 91. Here there is a drop of 15 volts. 5 3s are 15 volts. Here there is a rise of 7 volts. 76 to 83. Like that, if you write potential of across each of the terminal, if you are capable of writing potential before and after the resistor, potential before and after the battery. Battery will not be helpful to you, but potential difference across resistor if you can write it. Suppose now I want current through this. What is the potential difference? Delta V by R, it should be I. What is delta V? 83 minus 63 by resistor is 4. 83 minus 63 is 20 by 4. 5 amperes. Current you got back. Not only across this 3 ohms resistor also you can get it. Across this 3 ohm resistor, 91 minus 76 is the potential difference by this 3 ohms resistor. Delta V by R should be I. What is this? 15 by 3. 3 ones are 3 5s are 5 amperes. You got that. So, not knowing potential difference across multiple resistors, individually every resistors before and after the resistor, if you know the potentials, you know the potential difference. Basing on the potential difference divided by resistance, you will get the current. Similarly, we will take another example. If you have branches, then what to do? Yeah. Use some numbers as you like. 2, 3, 4, 5 ohms, 6, 7, 8 volts. Points A, this point is at B, this point is 0, O, this point is C. Let us say that 7 amperes current comes like this and goes into 2 amperes and 5 amperes. I have written everything, but I don't have right to write like that because I already written the potential differences. They will decide what current should come and what current should go. So one of the current I should take I in that case. So whether it is incoming current or outgoing current, the junction rule will decide, not me. I only say 7, I only say 2, every number I only take. Then what's the purpose of the problem? I am not supposed to do so. So accordingly, first I should find the potential difference between the different terminals, assigning one potential, say 0 at some place. Say instead of this I will take here the current and I this I will remove it. See, this is 5, this is 2. So this is say 3 amperes. We hope that there is some other terminal connection which decides the potentials of these points. Then we can take. So suppose this is at 0 volts. 5 amperes is coming like this, so plus 2 minus 0, a drop of 5 2s are 10, so this point will be at minus 10 volts. Drop of 6, minus 16 volts. 5 3s are 15, minus 31 volts, so this point will be at minus 31 volts. Next, current is going out and out, plus minus. 4 2s are 8, so minus 8, 31, minus 31, minus 8, minus 39. This point is at minus 39 volts. Minus 39, minus 7. B will be at minus 46 volts according to this diagram. So 3 amperes is coming. Plus minus. 3 5s are 15. 31 minus 15. Minus 45, 6 minus 46. So this point is at minus 46 volts. Minus 46 plus 2 minus drop. Minus 8 volts. Minus 54 volts. So point B is at minus 46 volts, this is at minus 54 volts, this is at 0 volts. Accordingly, if you write it, then the potential difference 31 minus 16 by 3, you will get this current. 46 minus 31 by 5, you will get this current. 39 minus 31 by 4, you will get this current. You will get it. And these currents are governed by, this should be kept at minus 46 by the battery, that side. This 54 should be maintained by some other battery. This 0 should be maintained by some other battery. So it's a part of a circuit, not the total circuit. It's a part of a circuit. If at all we are interested not in between potential at every point, but we are interested in potential difference across A and B, in between things not required, then we are permitted to do so like this. 2 plus 1, resistors wise you can directly add them. 1, 2, 3, 4, this should be a part of a single branch. 1 plus 2 plus 3 plus 4, this is equal to 10 ohms. Batteries wise, which is the big battery you see, this is the big out of all. So this will decide the total sign as of now. So 100 and 10 both are in the same direction, big bar, small bar. So 110 this side, minus 30, minus 20, minus 50, 110 minus 50. So you will get like this finally, 110 minus 50. This is A, this is B. So 110 minus 50 is 60 volts. So if 5 amperes current is coming like this and A is say 100 volts, 5 tens are 50, 100 minus 50 and minus 60, 110. 100 plus 2 minus there is a drop, plus 2 minus there is a drop. 5 tens are 50, there is a drop of 50, left over 50, 50 minus 60, minus 10. So B will be at minus 10 volts. This is permitted. Even if you do separately also, finally you arrive at that answer only. This permission is granted. Whenever you want, you can use it. See, this concept you try to understand. Potentials doesn't matter. Potential difference does matter. What is that? Let us have a battery of 10 volts and resistor of 2 ohms, the simplest way. Let us take this point as A and this point as B. Take A as 0 volts. Then according to this lecture, minus 2 plus there is a rise. So this should be plus 10 volts. As there is no gadget eating the energy, so this is 10 volts. As there is no gadget eating the energy, this is 0 volts. So potential difference is 10 to, if this is high, this is low. Current will flow like this. So I is equal to 10 minus 0, potential difference, delta V by R. R is 2, 5 amps. Now let us take the, so potential in this case A is 0. Now repeat the problem with 2 ohms, 10 volts. Let us take this point to be 0, which previously we took 10. Plus 2 minus there is a drop. So this should be at minus 10 volts according to our convention. As there is no resistor to eat the energy, there is no battery to pump the energy. So this point and this point will be at same potential, 0. This will be at minus 10. Compared to minus 10, 0 is more. So it will flow from this side to that side. 0 minus of minus 10. Potential difference is subtracted. Divided by resistor. Delta V by R. That should be I. That should be minus of minus 10. 10 by 2 is 5. Similarly, we repeat the calculation. 10 volts. If I take this terminal to be 100 volts, plus 2 minus, there is a drop. So this should be at 10 minus 100 minus 10, 90 volts. So this point will be at 100 volts, this point will be at 90 volts, and this is 2 ohms. I is equal to delta V, 100 minus 90, current, this is higher potential, this is lower potential. So automatically we will get 5 amps. In all the cases current comes like this only, and all the cases it comes 5 amperes, 5 amperes, 5 amperes. So this problem conceptually reveals one basic idea that potential does not matter, potential differences matter. Potential of this point, once I took 10, once I took 0, once I took 100, same point. In other case 0, 90, 10, minus 10. Answer came same. That means this battery will decide what's the potential difference. Potentials you can assign whatever number you want, but the battery and the current flowing through a resistor will decide the potential difference. So potentials doesn't matter, potential differences matter. So some teachers, even they take, if you take it as some arbitrary V, then plus 2 minus its fall, it should be V minus 10. So across this, V potential minus V minus 10 by R 2 plus V minus V gets 10 minus minus plus 10 by 2. Even if you take a variable, even if you do not take an numeric, answer comes same. Try to think the importance of potential difference, not the potential. Now students, let us see these problems which are to be solved using Kirchhoff's laws only. You have multiple batteries and resistors, and Here they are neither given in series nor given in parallel. But here there are three different varieties of questions. These two belong to level 1. This is level 2 and this is level 3 question. Actually there is no much difference, you don't even need to segregate them, but I will tell you the reason. You have a branch which have only battery without a resistor, you have a branch with a battery without a resistor, whereas here you have battery with resistor, resistor. When resistor is involved, when battery is involved, before and after you know the potentials, but when resistor is involved, until unless you know the current, we cannot tell what is the potential difference. Similarly here, branch with resistor, battery, resistor is there, resistor is there, resistor is there, resistor is there, resistor is there. So if we have a branch with battery without a resistor, the problem becomes simple. Let me show you. As I told, potentials are not important, potential difference is important. If you take one of the potential to be 0, addition subtraction becomes more easy. Let us take this point to be at 0 potential. Then there is no battery here, this is at 0 potential. Then this is at 0 potential. Written like that. And we are interested in this potential. As we are turning like this, there is a resistor in middle. As you are going like this, there is a resistor. As you go like this, there is a resistor. As you go like this, there is a resistor. But if you go like this, there is no resistor. Battery, -2 plus. Big bar plus, small bar minus. -2 plus, there is a rise. So this point is at 10 volts. Once you written all of them, is it possible to write potential? You see, this is small bar, this is big bar. So -2 plus, there is a rise of 2 volts. From here you cannot go because this battery is, this resistor is there. From here you can come down. So this is also 10. -2 plus rise, 10 plus 4. So this point is at 14 volts. So you have to draw two diagrams. One diagram before I assign the potentials. Whichever potentials are there, nicely I am putting 0 so that over that I am writing a circle so that you understand the new things. Better to use two color pens. Diagram before and after. Now you know potential difference. Which is more, which is less. 10 is more, 2 is less. So current will flow like this. 10 minus 2 by 2. 8 amp. So 4 amperes. 10 minus 2, potential difference is 8 by 2. Similarly, if you are coming like this 10, there is a drop of 2. So this should be 8 volts. 8 minus 0, 8 by 2. Potential difference by resistors. Resistor. If you want, I can write it here. 10 minus 0 by 2, that is equal to 4 amps. This is directly I am writing. 8 minus 0, that is 8 by 2. 8 by 2 is 4 amperes. So this is a 4 ampere current. Next, what else? Potential difference is known to you. 10 and 2, 10 and 0. Potential difference. 10 minus 0 by 2, 5 amperes. Outgoing, outgoing, outgoing. Is there any incoming current or not? Let us check. Okay. Here, 14 minus 0 is 14 divided by 2, 7. So potential difference is like this, 7 amperes. So this 7 amperes might be coming from here, 7 amperes. So it's not possible to have all outgoing currents without incoming current. That will not take care of junction law, conservation of charge. So this current 4 amperes, this current 7 amperes, this current 5 amperes, this current 4 amperes must be added to this. So we'll redraw the circuit. There is current like this 7 amperes. There is outgoing current like this 4 amperes. There is outgoing current like this 4 amperes. There is outgoing current like this 5 amperes. So if all are outgoing currents, that violates the law of nature. So it should be incoming current from here. There must be incoming current from here. So that incoming current must be how much? Sum of all these things. So if you write this as I, so incoming current you take plus, remaining all minus 4, minus 4, minus 5, minus 7 is equal to 0. I should be equal to 8 minus 7, minus 8 minus 7 is 15, 20. Minus 20 goes outside, becomes 20 amperes. So this should be 20 amperes. So there must be a current going like this, which is 20 amperes. This 20 amperes splits like this, 4, remaining 16. It goes 4 like this, remaining 12. It goes 5 and 7. So we solved a circuit. without doing anything. Just you have ascend the potentials and solve the problem. Same way, here also the problem is easy because you have a section where there is no resistor, and if you take 0 here, again you will get different numbers here. Better to take 0 here so that more of zeros you can handle it. Ante, that means you can take this as 0 or this as 0. Many terminals will get covered. So now 0 as a drop of 10 plus 2 minus, there is a drop. This is not plus 10, this is minus 10. Be careful. Right. Next, 0 minus 2 plus, there is a rise, plus 2. So this point will be at plus 2. Minus 10, minus 2 plus rise, plus 4. So this should be minus 6. This terminal. 0, rise of 2. 2 volts. Now you got, without solving the problem, solve the problem. That's why I told these problems come under level 1 where they are easy. One by one we are doing. Okay. Now see, this point is at 2 volts, this point is at minus 10 volts. Which is high? The one which is at 2 volts should be higher than minus 10. So 2 minus of minus 10 plus 10, 12. 12 by 2, potential difference by resistor. 12 by 2, 6 amperes. So 6 amperes current comes like this. Next, except this junction you do for all. 6 minus 0, which is higher potential. 0 is at higher potential, minus 6 is at lower potential. So current flows like this. 0 minus of minus 6 plus 6 by 2, 3 amps. Next, this is 2, this is 10, which is at high potential. 2 should be at higher potential, 10 should be at lower potential. So current should come like this. 2 minus of minus 10, 12, that is 6. 12 by 2, that is 6 amperes. So 6 is coming like this. 3 is coming like this. 6 is coming from here. What else? One more branch is here. How much is that? Incoming, incoming, incoming. You cannot have one out, that also incoming. That should be outgoing. Let us write that as I. I minus 6, minus 6, minus 3. Incoming, 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 minus 2, I put 0. So, I should be equal to 12 minus 15. So, I should go to plus 15. Let us take, instead of this is outgoing, you take it incoming. What happens we will see. This is also minus. So minus I is equal to plus 15. I is equal to minus 15. So answer is saying that 15 amperes current, but your sense of direction is wrong. You have taken wrong direction, so you have to take minus. So it should be reversed. Even with the law, you can, even with the mathematics, you can get the answer. Even with your common sense, you can get the answer. Like that. So this is another problem which is relatively easier than these two. Where the trouble comes. So what about this? I told incoming, incoming, incoming. So this should be outgoing 15 amperes. Then I will take care of it. Now coming to this point. So if I take this is 0, this potential to be 0, this potential to be 0. Just by inception, just by view, I cannot tell what is the potential of this point because everywhere resistance is coming in the middle. Okay, to some extent I can go from here to here and say there is a rise and this point to be at 4 volts. But this is not sufficient. Still I want this point. So what to do? Let me solve this problem. Okay. Now take this unknown value as x potential. X potential. So we need to find that x. We need to find x. How to do that? Let us take all currents to be outgoing. I1, I1, I2, I3, I4, In the beginning only I can say that my assumption is wrong because all cannot be outgoing current. One of them should be incoming current. It doesn't matter. I1 plus I2 plus I3 plus I4 is equal to 0. That means at this junction I am taking sum of all current should be 0. That means to get 0, if there are 3 of them are non-zeros, 3 of them are positive, 1 of them should be negative. 2 positives, 2 negatives. 1 positive, 3 negatives. Then only 0 is possible. So I kept my concept inside directly. So one of the direction will be wrong. Let us check like this. X minus 0, there is potential difference. So this is I1. So I1, I2, I3, I4. This way. X minus 0 by 2 plus x minus 4, this point, by 2. And what is nothing but I am writing potential difference. This potential difference, how much? 0, rise of 10. So this should be at 10 volts. X minus 10 by 2 plus this side, this is x, drop of 2, this x minus 2. This side, x minus 2 minus 0 by 2. X minus 2 minus 0 by 2. This sum should be 0. I get the proper potential of x which decides all these things. Okay. So some students ask me why you take all resistors to be 2, 2, 2, 2. I don't need to do the LCM part. If I take 2 ohm, 3 ohm, 4 ohm, 5 ohm, then I have to make a complex LCM. Unnecessary. See, my interest is to show you, teach you Kirchoff's laws, not to teach you the complex, the lengthy calculations. So LCM is 2, x plus x plus x plus x, 4x, 0, minus 4, minus 10, minus 2, minus 16, equal to 0. Cross multiply. This part you can do it very orally, that's why. So 4x is equal to 16, x is equal to 16 by 4. I mean 4. So this x should be 4. Let redraw diagram again, otherwise now you can do it. 4 minus 0 by 2. So this I1 should be 2 amperes. 4 minus 4. So current in this should be 0. 0 amps. Current will not flow through this. 4 minus 10. It cannot happen because 4 is low, 10 is high. So current should come like this. 10 minus 4 by 2. 6 by 2. This is 3 amperes. So 2, 0, 3. Incoming, outgoing. How much is this? X minus 2, that is 4 minus 2. That is 2. 2 minus 0. 2 by 2. So this part is 1 ampere. Just check whether it is following your KCL, Kirchoff's current law. 3 is coming, 2 and 1 is going, so here current will not go. That's true. So our calculation is properly done. But you can put this question as level 2 question because we used a calculation other than the diagram. There you have to do much more calculation. Let us see that. Yeah. See here, as usual, more of the terminals, if I have 0, it's more convenient to me as there are no resistors and batteries, all are zeros. If any possibility is there to write other terms, we write it. This is 10, rise of 10. Here I cannot write, here resistor is there, here resistor is there, here resistor is there, no chance. So this is some point which is x, unknown. Again, to our headache, there is one more point which is y, that is also unknown. But we know that x minus 10 is y, as there is a drop. So that you keep aside, x minus 10 should be y. One equation you set aside. Now, for x, you write all currents outgoing like this, like this, like this, like this, to be 0, sum. Okay. X minus 0 by 2 plus, you come from here to here, plus 2 minus, minus 4. So this is x minus 4. X minus 4 minus 0 by 2 plus x minus 10 equal to y, keep aside. Next, this junction, x minus 10 by 2 plus it's going that side, right? That also x minus 10 minus y. There is no resistor here. So call that current to be I, plus I is equal to 0. That current you call it as some current I, towards equal to 0. Now we need to write for the junction Y. You cannot, in the same problem, you cannot say one current is incoming and other current is incoming. Both in, so from X point of view it's outgoing, so Y point of view it should be incoming. Now you cannot say that Y point of view take outgoing. So what happens is, let us take incoming current like this. Incoming current is negative, minus I. Remaining are outgoing currents, Y minus 0. We are writing Y to be higher, 0 to be lower, by 2 plus Y minus 10, this point will be Y minus 10 minus 0. Y minus 10 minus 0 by 2. Directly, Y minus 0 by 2. By taking all positive quantities, summation is 0 means there should be an algebraic number which is negative that takes care of some positive numbers and gives 0. So we have properly done. Now we have two equations. In one case I is positive, in other case I is negative. If you add both, this plus I and this minus I gets cancelled, and in all the cases 2 is common. So LCM is 2, x 3x minus 0 minus 4 minus 10 minus 14 y plus 3y minus 0 minus 10 minus 10 minus 0 minus 10 should be 0. So you are getting 3x plus 3y or 3x minus 3y. How you get concept? You have added them to cancel them. One is plus, one is minus. So addition y will be positive. So 3x plus 3y is equal to minus 14 minus 10 minus 24 goes that side, becomes 24. And you have this standard already. One equation is there, x minus y is equal to 10. Take this 10 that side, y this side. Solve. Multiply with 3, 30. Plus 3y minus 3y gets cancelled. 3x plus 3x, 6x. I didn't change the sign. 54. 6 nines are. X is equal to 9. 9 volts. Now put this x in one of them. So 9 minus 10 should be y. Y should be minus 1. Now you know x is 9, y is minus 1. Is it fitting or not? You see, 9, you have to drop 10. 9 minus 10 should be minus 1, right? It's fitting. So our calculation is correct. You don't need to recheck the backside of textbook answer and all. It's already done. Now you need to find currents. So use Kirchoff's law. Unknown current you called I. Used concept that x minus y is equal to 10. Solve the problem. This is why I told you this is a little tough problem. So this is x, what is it? 9. 9 minus 0 by 2, this is 4.5. 9 minus, this is x minus 4. 9 minus 4. 9 minus 4 is what? 5. 0 and this is 5. So current will come like this, 5 to 0. 5 minus 0, that is 2.5. So I have one current like this, which is 4.5. One current like this, which is 2.5. No. 9 minus 10. Current cannot flow from here. It should go like this. 10 minus 9 by 2, 0.5. 0.5 amperes. This one, keep it I as it is. Let us not bother about that in the beginning. We have another junction. Y was minus 1, 0, which is more, 0 is more than minus 1. So it comes like this. 0 minus of minus 1 by 2, 0.5. So current coming like this is 0.5. this one. Y minus 10, minus 1, minus 10, minus 11. Minus 11 and 0. 0 should be more than minus 11. So the current will come like this. 0 minus of minus 11 plus 11 by 2, 5.5. So a current of 5.5 amps comes like this. What about this? This is minus 1, this is 0. Current cannot come like this. Current should go like this. Higher potential to lower potential. So this should be 0.5. 0.5. Check out now. What about this one? 4.5. It should fit into our mathematics. Let us add this, this and this. How much are getting it? 0.5, 5.5, 5.5, 6.5. 5.5, 6, 6.5. 6.5 is incoming. So this current should be incoming. 6.5 should be incoming. And 6.5 should be outgoing. Let us check. For this 6.5, 0.5 gets added. It becomes 7. 7 gets split into 4.5 and 2.5. That's right. So this current will not go right side. In this battery, current will come left side, and that will be equal to addition of all these things, and that comes out to be 6.5 amperes. So now we finalize everything. (4.5), 2.5, okay. This is 0.5 up. This like this, 0.5 up. This current should be this side, and it should be 6.5. This should be 0.5. This should be 5.5. This current should be 0.5, and this Y should be minus 1 volts. If this is 0, this is minus 1. Accordingly, you can change the numbers. In this way, some circuits can be solved using Kirchoff's laws. These are the main varieties. How to write it and how to do it, I told you. Some teachers also follow another method, which is also a nice method, where they take these points to be A, B, C, D, A, B, C, A, C, D, A, D, C, F, G, A. Like that they write number of times the equation. Kirchoff's law, what I told you, basically Kirchoff's law, that they will write it repeatedly and they solve the number of equations. That becomes little tedious. Assigning zero potential and doing will reduce your calculation, because potentials are not important, potential difference is important. That anyhow will take care of the problem. So writing junction rule here, assuming current I1, I2, I3, I4, I1, I2, I3, I4, I5, 6, I7, I2. Number of writing KCL at this point called A, at that point called B, at junction A, at junction B. You have several other junctions also, writing them. Solving number of equations, I don't think is a feasible method. Even for student in between calculations also it will go wrong, and even after solving the total question you may not be able to check like this whether it's correct or wrong. So better to solve these problems like this. It's an easy method, and this method we also call it as assigning potentials method. Assigning potentials method. This is about Kirchoff's laws. In this lecture I couldn't cover cells, but in the next class I will cover cells. We will put that point P20.4A like that. This is 4A and 4B, we will do it. Let us do like that.